So myself, Srinivasan from the Department of Organic Engineering at Sri Sharma College of Engineering. Today I'm going to talk about single layer perceptron, which is most important topic in neural network systems. To understand the neural network system in terms of mathematical representation, we need to understand how a neuron works in our body. And we in our human body, we have around 10 power 11 neurons, and most of the neurons in our brain, and some of them are in spinal cord, and some of them are in our sensory organs like ear and nose, eyes, and so on. And if you look at that neuron structure, it has dendrites, soma, that is cell body, and it has axon, and it has terminal of your axon. And what are the inputs that it gets from the sensory organ? It has to pass through the dendrites, and it is getting summed up in the soma, that is cell body. Okay, then it is transmitted to axon, and axon at the end of the axon, or the output of the axon, we have the synaptic terminals, which conveys the information from the synapses from the one neuron to another neuron. That is the way it works out. So most of as I said, all the information flows from dendrites to via dendrites. Okay. So what are the inputs that we get from the sensory organ? And that is all called inputs, and it is getting summed up at the soma. Okay, each input will have a certain amount of strength. That is in terms of weight, I can say in my explanation. But here I can say it is a strength. Okay, each input will have strength, and it is getting summed up, and it is transformed to axon, and finally we get the output out. So this can be a model in terms of in the following way. See, for example, if you are going to watch a movie, and the most important thing we look at is music, music director, actor, actress, and so on. So these are all input features, I can say, in real-time examples. Before watching a movie, we look at all the important things, and based on that, we'll decide whether we want to watch a movie or not. So each input will have weightage. For example, I can say music director will have certain weightage, and actor will have certain weightage, actors will have certain weightage. So all these things will have certain weightage. So what is happening in this? And each input feature will be multiplied by the corresponding weights, and it is summed up, and finally it will be activated. So based on the actress, music directors, and music directors, and villain, and many, maybe consider many features, many things before watching a movie. So after this, when we get this movie is going to be good based on the reviews also. Reviews also one of the future, I can say. So based on that, we will decide and go and watch the movie. So it is getting, our human brain is getting activated, and finally we end up with watching the movie. Okay, this is the way our human brain works. So this can be modeled in terms of this way. The X1, X2 are the co-features, and corresponding weights are associated with that, and it is getting summed up, and finally it will be activators. Okay, so artificial neural network is basically a computational model. It is inspired by the biological neurons. Okay, so this is the way it works out. As I said, the mathematical representation of this, in each X1, X2 of the input features, and W1, W1, W2, W3 are the corresponding weights. Okay, so all will get summed up along with some bias term. I'll explain you why bias B is even over here. It is all summation is happening in the neuron. It is summation is happening, and it is getting activated. Finally, we end up with the output. Okay. See, for example, I can say that if you look at student get good grade in the exams, it is all based on the hours of studies and attendance percentage and the grades he has got, and everything has been considered whether he is going to pass and whether he's going to get pass with a good grade, I can say. Okay. So the hours number of it all depends on one. If a student gets good mark, it all depends on how many hours he has studied and what is the attendance percentage and everything. So we put all for all the cases we put the weightage, and it is getting multiplied here. So the X and Y is not possible because we can't multiply both the same matrix, and we have to get transpose it. One of the matrix should be transposed. That is here we are transporting the weight one. Okay. So it should be like, for example, I can say X is a matrix here, right? That the form is 3 into 1. There is a 3 rows and 1 columns. And weight has to be transposed. That will be 1 into 3. Okay. So the bias term is given over here. Why? Because mathematically we should not have we should not have. I mean, normally in if in human brain we don't have, we'll have minimum weightage for each features. So sometimes in mathematically, if you put 0 in all the cases and everything is going to be 0, so it can't be computed. So to avoid that, we add some bias term that is also constant. Very small amount of that amount is going to be very less, and that is going to be constant term over here. Okay. So what we are going here is that the linear combination of all those things we are combining here, that is represented in terms of yes. So that is represented in terms of sorry, that is represented in terms of z. Okay. So that z is going to be activated here, and finally we get output of it. Okay. So basically, when you have without bias term, and all these things will pass through the origin, because it as we know the straight line equation y is equal to mx, that passes through the origin, passes through the origin. And whereas if we have mx plus c, then it won't pass through the origin. It will have intercept in certain point of the line in x and x or y. Okay. So that's the reason now we are adding bias term in the equations. So the perceptron is a simplest and oldest form of neural network that has been introduced in the year 1956 by Rosenblatt, and it is considered as a supervised learning of binary classification. It output is going to be 0 or 1 or yes or no or true or false. Okay. So this is going to be a binary classification type. In simple perceptron, we don't have any hidden layer. We will have only input layer and we will have an output layer. There is no hidden layer in it. And it is basically used in the logical operations like AND or which will give you a binary outputs. So that in each operations will have a binary output. So that's the way it works. Okay. So what is happening? As I said in the previous presentation, it is getting multiplied and activated here. So x1, x2, we have the corresponding weights and it is getting summed up, and bias term is also added here. And finally, it is getting activated through a step function. If z is less than 0, then it is going to be 0. If z is greater than or equal to 0, then it is going to be 5. That is gear 1. So what is a perceptron learning algorithm? How we are going to update the weights? Because as in the previous slide, we have seen it is less than 0, 0, then the true value should maybe a 1. True value might be 1. And here it is going to be 0. So in that case, whatever we predict, that is going to be wrong. And we should have certain algorithm to update the weights and bias. So that's why that's where perceptron learning algorithm plays an important role. Okay. So what we are doing here is that we are updating the weight based. We are updating the weight based on the perceptron learning rule. Okay. So what is the perceptron learning rule is that new weight is going to be the combination of old weight plus del change in weight. The change in weight is nothing but based on the perceptron rule. That is when we are learning rate and target minus predicted and corresponding x. So the learning rate is basically used in the neural network system, which helps us to how quickly the model learns. So that's where that learning rate is important. So target is basically our actual one. The computer is basically the whatever we are going to predict after the activations. Okay. So the similar thing we can apply in the case of bias. Here it is going to be xi. Here it is going to be 1. Okay, because and always it is going to be 1. Whatever the input we get, it is going to be 1, and that bias term will have certain weights. Okay. Let us look at the simplest numerical problem on single layer perceptron. Okay. So we'll have two inputs, that is 1 and 2. Target is 1, and corresponding weights are going to be 0.2 and minus 0.5. Bias is 0.1. Learning rate is 0.1. So we can compute based on the step functions. And then now what the first step is basically z is equal to x1 w1 x2 w2 plus b. And this x1 is basically your input, and x2 is also going to be input. W1 is the weight, and B is the bias. So once you have this, after summation, it is going to be minus 0.7. And if it is a 0.7, it is less than 0, then we can say our predicted output is 0. So what we have to do is we have to update the weights. For this case, we have to come over here, and our old weight is going to be old weight we have to be considered, that is 0.2, and the new weight is going to be, we have to apply the perceptron learning rule, that is neta, error, and xi. So if you multiply all these things, we will end up with del W, that is 0.1, and finally we get W1 new weight is going to be 0.3, which is different from the given problem. Okay. So similarly, we can calculate for W2, and similarly we can calculate for the bias as well. So once we have calculate the new updated weights, we can apply that in the equation and see whether we are getting the predicted one and target one is same or not. So in this case, we applied and we didn't get. So we updated the weights, like using the perceptron learning algorithm or learning rule, and we got W is equal to 0.4, and W1 is 0.4, W2 is going to be minus 0.1. So transponding input remains same, and the bias is going to be a change from 0.1 to 0.3. Okay. See, if you apply all these things, and we end up with our predicted value is 1. Because our target is 1, and predicted is also 1, so there is no error in it. So we can say the updated weights are going to be remain same. Okay. So this is a way we have to update the weights till we get the predicted value is same as the targeted. So we have not talked about written AIS here, but it is a simple single layer perceptron. We have multi-layer perceptron as well, but we have so far we have discussed only single layer perceptron. This single layer perceptron is mainly focused on linearly separable data. Okay, so it can't handle the nonlinear structures. Okay, so with that, I can wind up the topic on single layer perceptron. Okay. So in this case, in single layer perceptron is basically you apply learning rule and try to get the learning rule and try to get the updated weights in the simple neural network model. Thank you.